All right. Hello again, and welcome to the Food Service Packaging Recovery webinar. This is our fourth webinar of the year, and today we're going to be focusing on recovery specific to Boston, successful recovery. Few technical details here. The session has started, so if you're seeing the screen and can't hear me, then you probably can't hear me, but want to make sure you can see the control panel on the side that allows you to have two features. One, to either hear us through your computer speakers, or two, if that's not going well for you, to use the call-in. You can click that audio button that'll give you both options, whichever one is best for you. Second, that control panel over there is the way that you can pose questions. You can hear us, but there's so many of you that we can't hear you, and that's okay. But we do want this to be a discussion, and we do want to hear your questions, comments, clarifications. And as the facilitator for this session, I'll keep an eye out on that Q&A on the side. And when I see questions come in, I'll interrupt the speakers if they're a clarifying nature, or we'll save all the other ones to the end. This webinar is being recorded and will be available for download afterwards. The slides will not be, but the recording will. So with that, again, welcome. I'm Keith Harrison, and I'm with Resource Recycling Systems, and I'll be the moderator for today's webinar. We've got a series of good speakers. Lynn, Bob, Ted, and Jeff will each take a minute to introduce themselves, and then we'll and tell us a little bit about their background, and then we'll talk a little bit about the project and what we plan to cover today. Lynn, would you like to say hello?
Sure. I'm Lynn Dyer. I'm the president of the Foodservice Packaging Institute. Thank you all for joining us today. But before we go any further, I do want to thank Bob, Ted, and Jeff for their time today. So I'll turn it over to you, Keith. Thanks.
Thanks. And Bob, why don't you give us your introduction? Tell us a little bit about yourself.
Sure. Good afternoon, everyone. Bob Capadona from Casella Recycling, which is the recycling arm for Casella Resource Solutions. I've been in the business for 30 years, started on the commercial side of recycling and evolved into the municipal side, designing and building single-stream MRFs throughout Casella.
Excellent. And Ted, how about you?
Hi, this is Ted Siegler. I'm a partner at DSM Environmental Services, a resource economist by training. Have been working in solid waste management for 35 years, specializing in recycling efficiency, and have been sorting waste ever since 1973.
Excellent. So Bob's going to tell us about the successful recovery of food service packaging in Boston. Ted's going to dig a little deeper into what we know about food contamination and residue in those materials through a recent study that he just completed. And Jeff, why don't you give us your intro?
Hi, good afternoon, everyone. My name is Jeff Riles, and I'm the general manager for the recycling division at the Kraft Group in Foxborough. And our group owns paper mills in the United States. We own recycling facilities, and we own box plants. So I'll be giving you some more background information on our company.
Great. And Jeff represents a market for the Boston Casella MRF in buying their OCC cardboard, which includes pizza boxes. So we'll get into a little bit of our end markets there. So the purpose of this webinar is to introduce you to work that the Food Service Packaging's Paper Recovery Alliance and Plastics Recovery Groups are doing to increase the recoverability of food service packaging. Lynn, you want to tell us a little bit more about your efforts?
Sure. Just a brief intro on FPI itself. We're the trade association for the food service packaging industry in North America. And back in 2011, 2012, we actually set up some independent working groups within FPI to work on voluntary efforts to increase the recovery of food service packaging. And we do use the word recovery because we want to look at all options that are out there to really divert that valuable material from landfills. So we're looking at options like recycling and composting and energy recovery, but we are looking at whatever is that highest and best use for that material. So while today's presentation is really going to be talking about recycling, please don't forget about some of those other areas that we're going to be focusing our efforts either currently or in the future. So as I mentioned, Paper Recovery Alliance, they work predominantly on the paper side. Plastics Recovery Group, surprise, surprise, works on the plastic side. while the two groups were formed independently, the two groups have really come together and I've been working quite closely because there are a number of different ways in which those products are actually co-mingled. I'm pleased to say that our membership with those two groups has really grown, and on this screen you can see the logos of all the member companies that are working on these voluntary efforts. With that, I'll turn it over to Keith, and she can give you a little bit more information on what the groups are actually doing.
Sure. So Resource Recycling Systems is happy to support this effort because there's such an interest in really growing not just the composting and energy recovery potential, but the full recovery that includes energy recovery, composting, and recycling. And in the recycling side, really focusing on resolving barriers from MRF to market. So this group has a very realistic interest in helping to create market-driven opportunities for the material. So not trying to stuff unwanted through, but really working with the entire system to see what we know about end markets, what we know about bales that are traveling through a system, what we know about the behavior of fate of materials inside the MRF, and working around the barriers in each of those, using those barriers to stack up our to-do list of how to successfully recover more materials. And we do understand that communities all across the country and Canada are looking to expand what they can collect. And they're hearing from their public that the public wants to be able to recycle more, but it's a business, and we need to make sure that the opportunity to recycle is a trusted one, that the end markets are solid, and that's why we focus on our MRF to market work. Our current emphasis on materials really drills us down into cups, containers, boxes, and paper bags. So those takeout materials similar to what you're seeing on the screen. Why these? They represent over 65% of the food service packaging blend, and we also see that they can dependably travel through a MRF, and we think that there is good access for them to hit existing bales and get to the recovery markets that are hungry for more fiber, for more resin material, and that's one of our key focuses of work right now, is really engaging the marketplace to accept more of these materials. We're going to spend a fair amount of time talking today about one specific example, and that's the role of pizza boxes in an OCC bale. And I know that it's one of the biggest questions of, can pizza boxes go in the recycling bin? It's kind of the classic in there with, caps on or caps off your soda bottles. And of course, that one, more and more people want the caps on so they can get that good material. And what we see in Boston is a successful recovery of pizza boxes into their OCC bale. When talking with MRFs and end markets about what they can expect when they look to increase their recovery of food service packaging, we look to discuss, as I said earlier, the behavior of the material inside the MRF, the fate of which bale it ends up into, and then how it affects the bale. So some of the things we've done is create projections of if there's a 10% recovery rate, and all of the material that could hit that OCC bale does effectively move through and get there, what sort of tick would you see in that bale? How much change in the makeup of that bale could be expected? Now, why a 10% recovery rate? Well, we've got to get started somewhere, and we know that plastic bottles enjoy about a 30% recovery rate, so we thought we'd start with an optimistic gung-ho effort, but still one that's reasonable, and that's where we get to 10%. And we understand that if all the pizza boxes and the craft carry-out bags did hit the OCC bale successfully, it's still less, or a roughly 2% change. One thing that's not captured in here is the possible addition of sleeves for takeout cups. That might be an additional tick of OCC, very good OCC material there. But it's interesting to keep the generation in perspective as we talk about this material. So with that, I was hoping we'd pass the ball to Bob to talk a little bit about what he has going in Boston. Bob, I'm going to pass the ball to you. Let's see. All right. Bob, I think the controls should be coming your way. Good. You can see your screen.
Gotcha. Thank you. Good afternoon, everyone. Just a small disclaimer here. I apologize in advance. I caught a little cold from my kids that came home from school over Thanksgiving, and if I sound a little awkward, I apologize, and we'll fight through it over the next 10 minutes. Just a quick, brief overview of Casella as a whole. The picture that you see in the bottom of this screen is actually our Rutland MRF in Rutland, Vermont, that was retrofitted back 2 years ago. You'll see throughout the presentation here the coined term zero sort. It is our brand name for single stream. We as a company feel single stream is a very genetic word, and zero sort, there is a little bit of expertise behind processing and marketing of that material. So you'll see a little bit of zero sort throughout the presentation here. Background of Casella, founded in 1975 by John and Doug Casella, a single truck out of Rutland, Vermont. They built their first recycling center in 1977, and we currently operate in 7 different states, mostly in New England and New York. We just introduced into Pennsylvania, purchased a landfill a year and a half ago. And 1,700 employees serving over 200,000 customers, and of course we are a publicly traded company. Over the years, waste is kind of is a term that's now gone by the wayside. We are a resource solution company, and we're pretty proud of the fact of some of the first movers in different areas of the company. And you can see in this slide, we were the first from a single stream standpoint to build and design facilities in Vermont, New York, and Massachusetts, and our first line of fleet in Vermont in the CNG trucks, and the first in the landfill gas power plant in Maine. And we just built an anaerobic digester in Massachusetts just over a year ago in Rutland, Massachusetts. And Casella Recycling is of course, the recycling arm of Casella. And a little overview of the recycling component is 12 recycling operations, processing over 600,000 tons per year. Of the 12 recycling facilities, 5 of them are zero sort MRFs, 2 in Vermont, 2 in Massachusetts, and 1 in Stanley, New York. The balance of the facilities, the other 7 facilities, are your traditional dump and bale facilities that would process source separated material. We do have a facility coming up in Lewiston, Maine, scheduled to open up June 2014, and it is a single stream MRF scheduled to open and process 30,000 tons beginning again in June. Since the subsort that Ted's going to discuss was performed in the Boston facility, thought a little background of that facility itself. It is quite a large facility, as you can see, one of the largest in the country. Processes over 200, on schedule to process over 220,000 tons in 2013, and has the ability to process 45 tons an hour, serving over 50 communities in the metro Boston area, several districts of the city of Boston. Runs 2 shifts, 110 employees in a 70,000 square foot building. And again, it's a pretty sophisticated systems with 8 optical sorts, a 3-deck OCC screen, 2 newspaper screens, and over 200 conveyors. And here's a quick overview of our acceptable list. Zero sort, it's pretty traditional with 12 to 14 different commodities. The new one in the bucket, as you see, is a large rigid plastics, the bulky rigid plastic, which was introduced about 3 years ago. And then you have the glass, which by weight is typically 20% of the stream. And then we have the metro Boston area, which is very similar to the acceptable list that was the previous slide. I put this up because you can see this is exactly what is on City of Boston's website, highlighted pizza boxes. And a little background on that, 4 years ago, the City of Boston approached Casella and was curious if pizza boxes was an acceptable item. And doing the right thing, we just kind of the middleman who had to get out to our mill buyers, which was probably a half a dozen in the Boston market that we sell OCC to or cardboard to, and got the okay from all of them to accept pizza boxes within the stream. And really it came down to kind of trusting the consumer that they're going to do the right thing. Obviously food waste is just not, it can't be tolerated. It's zero tolerance from a recycling standpoint. And I'm sure Jeff Riles from Grand Whitney will expand on this a little bit as to how it came about. So just a little background on the history of pizza boxes within the stream here. And from a quality standpoint, I think it's really important, since we're talking about food service packaging, the keys of quality of material. Really, the MRF operations changed 10 months ago when Operations Green Fence came into play. And for those of you that are not familiar with that, it was a government-instilled policy by the Chinese government to crack down on pollution and contamination and trash coming in imported into China. The policy was anything under 1.5% contamination was deemed rejectable, and it was supposed to be a exercise over a 10-month period, which is just ending now. My gut tells me, and my experience tells me, that it will not end now. I think this is something that will stay here, and it will be a crackdown on all exporters going overseas. So the keys to quality of material, now that the Green Fence has enforced and made every MRF step up from a quality standpoint, is the incoming stream. It is very much difficult to process 12 different commodities in one stream as it is, and if that stream is not clean and further contaminated by food waste, bowling balls, dog chains, we've seen it all over the past 10 years, and it's very important that the incoming stream is clean. We get out to the generators and form that partnership and public outreach with regards to keeping it clean. Of course, the equipment and design, there's some expertise in how to design equipment, especially from the flow as to where in the system you extract glass, where in the system you extract fiber from plastics, where do you want to put the eddy current. It's very important that that expertise is there from a quality standpoint and separation standpoint. And then there's the operational expertise. You just don't invest $4 to $10 million in equipment and expect a manager to go in without any experience and just turn the key and start it up. It is every one of our managers has at least 10 years of experience. They share best practices. They understand that last bullet point is a throughput design, which is we have MRFs that process 15 ton an hour up to 45 ton an hour. And the most important piece is if it's designed to process at 15 ton an hour, you run it at 15 ton an hour. The human nature would tell you that if there's 500 or 600 tons of material sitting on a tip floor, that manager is going to want to push as much through as possible, and now you're compromising quality. Whatever that system is designed, you stick with that. Our motto really is the turtle will always win the race. Turtle wins the race when processing material. So really the last slide is successful programs. It's all about teamwork. Partnership is so important for that generator to understand where your material is going. Have a relationship with that MRF. Ensure that they where the end markets are, how they're processing it. You can see by the separation, you can see by the end product whether it's clean, whether they really have the expertise. So it's so important from a partner and communication standpoint. At least once a month, go over and see where your recyclables are going. Make sure they're being processed in a friendly manner. Education and outreach, very important. However, that outreach is performed from a generator standpoint and ensuring the acceptable list is in place, whether the last piece is the tours. Really, I can tell you that every one of the MRFs that we operate has an education center, and by far it's the most beneficial item within the facility. you can explain how separation, you can explain how disc screens work, but to see it in action is really is the belief to see it. So I would encourage anyone that has not been to a MRF, definitely get out to a MRF, watch the separation, watch how the disc screens work, and most of all, watch the end product of the 12 or 13 different commodities at the end of the stream. So with that, I think I'll hand it back over.
Great. I think we'll pass the ball over to Ted. And thanks, Bob. I think that I got a couple questions coming in for you about what does zero tolerance for food waste mean, or food residual. And I think we'll get through Ted's conversation and Jeff's too, and then we'll loop back around about the overall of how it all comes together of what food residual means. But certainly to FPI's PRA and PRG, the concern, food residual is a big concern. And so what we're looking for Ted to talk about is a study that he just recently completed to see if we could discern a higher or lower rate of food residual on food service packaging as compared to other traditional recyclables that are in there, like pasta jars or other food packaging outside of the food service packaging realm. So, Ted, you ready to take it away?
I am. Can you see my screen?
Yeah, it looks good.
Great. Then I will start. As it says here, this was a food service packaging contamination analysis that was done kind of as an add-on to the Boston recovery rate study that we did for the city of Boston. To put it in context, DSM and our subcontractor, NSW Consultants, contracted by the city of Boston to conduct a recovery rate analysis to look at the difference in how much people were recycling if they got 3 garbage collections in 1 recycling day per week or 2 garbage collections in 1 recycling day per week when compared to the areas of the city that have a single day of recycling and refuse collection, what we're calling parallel collection. The sampling and sorting occurred over 2 weeks in the fall of this year. We randomly selected representative setouts of refuse and recycling from each of the sections of the city that were included in the study. All the recycling and the refuse was sorted by type and weighed. All of the recyclables set out for recycling were sorted into the same categories and weighed. And then we calculated a recovery rate by material type. And the formula is down below. It essentially is how much of each recyclable material was set out for recycling divided by the amount of recyclables set out for recycling plus the amount of recyclables found in the refuse expressed as a percent recovery. Since we were doing all of this sorting, we were asked by Keith to look at the possibility of adding this food service subsort to our sorting, and we agreed to do it. So it became an add-on to our existing study with the city of Boston. We were fortunate enough to have Casella agree to allow us to sort at their facility in a designated area. Bob and I go way back. He's unfortunately had to host a number of sorts that DSM has carried out for Boston and Cambridge over the last 15 or 20 years at that facility, so he's kind of used to us. But we sorted there, and all of the material that we collected on the streets in the sections of Boston are delivered to this facility. So it's a logical place to sort. And as Bob pointed out, all recyclables accepted at the Casella MRF are included in the materials that Boston requests households place in their recycling bins. And Casella allows certain types of food service packaging to be included in the materials delivered to the MRF, which is why Keith was interested in adding on this subsort. As I said, we entered into a subsort agreement or a contract to do the food service subsort. Funding for this food service subsort was provided by the FPI, and Keith was the project manager. We sorted 4,620 pounds of recyclables from the 4 neighborhoods over the 4 recycling collection days, and all food service and food contact packaging was pulled out of the recyclables by material type and set aside for a visual evaluation of contamination levels. And I'll talk a little bit about that. The material types that we were looking for were mixed paper, corrugated containers, plastic tubs, lids, and clamshells, aluminum trays and food cans, and steel cans, which were really just a control since there are only food contact steel cans. This just gives you an idea of what the difference between food service and food contact packaging is from the definitions that we used. So food service, in this case, we were assuming it's packaging used by restaurants, delis, and fast food establishments to package food consumed away from the establishment. And I'm giving you kind of a mini list of the types of materials. Obviously, pizza boxes and rounds were one of the big ones. Supermarket deli counter take-home packaging, hot and iced coffee cups, carry-out paper bags from fast food restaurants, although we didn't see very many of those, paper plates, and paper and plastic clamshells holding fast food or restaurant leftovers. That can be compared against food contact packaging, and in this case we're talking about packaging that comes in direct contact with food. So a spaghetti box that has spaghetti inside of it, or an ice cream package, a plastic clamshell that might have your organic mixed lettuce, tubs and lids for yogurt or butter, and in the case of corrugated, it's primarily boxes used to ship bulk quantities of produce to supermarkets, and as I said, steel food cans. We excluded any packaging with a plastic pouch separating food from the packaging, like a cereal box. We developed a visual ranking system for all of food service and food contact packaging on a scale of 1 to 5. We spent the first day that we actually collected recycling developing the ranking system, with 1 being the cleanest and 5 being highly contaminated with food in or on in the package. It was necessarily subjective, but we tried to be consistent throughout the 4 days based on the ranking criteria established on the first day. And I'm going to give you some pictures so that you have some context into how we rank them. So this is a mixed paper ranking 1 through 4. The 5 would have had food, actually big chunks of food on it, to show you how clean a 1 is and how dirty a ranking of 4 would be for mixed paper. This is a similar ranking for pizza. Again, if the pizza box contained pizza crust or pizza in it, then it would be a 5, so that you can see kind of what the difference is in the rankings in terms of, in this case, primarily grease on the pizza boxes. This is the one that we probably had the largest number of containers. This is plastic tubs, lids, and clamshells, showing very clean material on the left, which is a 1, going to a 5 on the far right, which is kind of food in the container as opposed to just on the inside of the container. I don't have good pictures of aluminum and steel cans in terms of comparison, but we use essentially the same methodology, although it's fair to say that almost all of the steel cans were ranked as a 2 if they had food in them, and we saw very few containers that would have a lot of food in them that was a 5. So I'm going to give you a quick rundown of the results from the work that we did, and I'm going to use the plastic packaging as an example. For example, we had 228 pieces of food contact and 109 pieces of food service plastic tubs, lids, and clamshells were sorted and visually ranked from the sample of recyclables that we collected from the south end of Boston, which was one of the 4 districts that we were studying. And we basically added up all of the food contact and food service packaging that was ranked as a 1, all that was ranked as a 2, and so forth. And then we created a percentage. So if in the case of food contact packaging, 83% of all of those 228 pieces of food contact packaging was a 1, ranked as a 1, in other words, very clean. and 89% of all the food servicing packaging received a ranking of 1 for that day. This ranking was carried out for each material type and for each of the 4 days of the sort. And the general results are pretty simple. With the exception of corrugated containers, there was no appreciable difference in contamination rates between food service and food contact packaging. So what do I mean by appreciable? That is the difference in the percent of pieces falling into each category between food contact and food service typically was within 10 to 15 percentage points of each other, but more importantly, the variation was independent of whether it was food service or food contact packaging. So on one material, you might have, say, 85% was ranked 1 for food contact, and 75% was ranked 1 for food service. But on the next day, the order would be reversed. So there was no, if you looked at a trend line across all of the 4 days of sorting and across all of the materials, there was no appreciable difference in the level of contamination between food service and food packaging materials. As I said earlier, the only difference really was in corrugated. And in this case, it's probably important to, and I'm bringing back up the picture of the ranking of corrugated. Virtually all of the food contact corrugated was bulk produce boxes with no contamination. So not surprisingly, pizza boxes did contain some contamination, especially grease. However, in all of the cases, between 75 and 80% of all of the pizza boxes that we sorted out were ranked between a 1 and a 3. And you can see from the picture on the other side that even a 3, while it certainly has some grease contamination, is not significantly contaminated when you compare it against the type of food waste that you see, for example, in a PET yogurt cup or a butter cup. But there certainly is more contamination here than there would be for the bulk corrugated containers. So what are our conclusions and cautions? As I said earlier, no appreciable difference in contamination levels between food service and food contact packaging, and even for corrugated containers, the level of contamination was relatively minor. However, and this is a really big however, all recyclables that we sorted from all of the areas of the city were exceptionally clean when compared to other cities that we have sorted in. So the results may not be representative of cities other than Boston. So while we can say with some confidence that in the city of Boston, for the materials that are accepted at the MRF, there is really no difference, it would certainly be necessary to do additional sorting in other cities in order to be able to say that that was the case in other places. The interesting or the exciting thing from DSM's perspective is that the acceptance of fast food packaging, while it's not promoted by Casella, and therefore we did not see enough to really draw a lot of conclusions, what we did see certainly indicates that it is a potential new frontier for expanding materials recycling. I happen to be a big fan of Dunkin' Donuts coffee, and anyone who's in the recycling business, wherever you go, you're always looking in the trash to see what's in there, and it's pretty clear that at a coffee place like that, virtually all of the material that's going into that trash is probably PET or a relatively high quality paper that would have a market if the food contamination was not too great. So this study from DSM's perspective certainly is an interesting way to expand the amount of material being accepted for recycling. And that's the end of my presentation.
Thank you, Ted. I see some questions coming in for you, but all of the expanding nature, not the clarifying ones, so we'll save those to the end, and we'll switch over to Jeff. Jeff, are you ready to lead us through some of your discussion?
Yes, I am.
Okay.
Hi, everyone. My name is Jeff Riles. I work for the Craft Group in Foxborough, and I'm going to be running through the portion of our paper mill in Connecticut, which is named Rand Whitney, and I'll get started now. The craft group is primarily made up of 4 divisions. We have a forest products and packaging division, sports and entertainment division, a real estate division, and a private equity division. For the forest products and packaging, we have a brokerage company which is called International Forest Products. That company was established in 1972, and we broker or trade about 3 million tons of forest products through that company each year. Rand Whitney Container is our plants that actually make cardboard boxes. We have 5 of those plants in the Northeast. And then Rand Whitney Container Board is our paper mill in Monmouth, Connecticut. And that mill produces brown paper that eventually gets converted at our box plants into new cardboard boxes. Rand Whitney Recycling, our recycling plants, we own and operate 3 small recycling plants that are basically push and bale. They're not single stream, or they're not very similar to what Bobby Schmitz for Boston. Ours are much more simpler, I would say. Excuse me, I'm having a little trouble changing to the next slide here.
Is it frozen?
Yeah, it's frozen. Is there a way to advance the slide?
I can. Why don't we try this? Why don't we make me the presenter, and I'll pull up your deck, and you just tell me to advance. So give me 1 second to get that up. And let's see. Okay. We were here, right? Ready to go to the next one?
Yeah, ready to go to the next one.
Okay.
Sorry about the technical difficulties there.
No problem.
The next slide, if you look at the picture on the bottom left, that is a picture of one of our box plants where we manufacture cardboard boxes. And then all the way to the right is a picture of what a roll of linerboard actually looks like. So that's what the finished product looks like from our container board mill in Monmouth, Connecticut. And we could move on to the next.
Okay.
This is a snapshot of the overall OCC market in the USA. Last year, 29 million tons of OCC were recovered. 50% of that went to make new container board in the United States. 35% of it was exported, with the majority of it moving to China. And 15% was put into other recycled paper boards. We could head to the next one. Here's just a little snapshot on our mill in Connecticut. It was built in 1994. We produce about 250,000 tons a year. And we are 100% recycled. So we buy 100% recycled OCC and also a little bit of double line. Next. Again, this is just another kind of tidbit on our mill in Connecticut that we produce 250,000 tons a year, which we have to buy about 50 million pounds of OCC per year, which is the equivalent of 150 miles of OCC stacked end to end. I'll go to the next one. Here's just a picture of quality that we generally buy for our mill. The picture on the left is baled up OCC, and the picture on the right is baled up DLK. DLK stands for double line clippings, and that's actually the trim that comes off of our machines when we're converting the rolls of paper into cardboard boxes. Next. Below here is a picture where it's just showing our warehouse in Connecticut, and basically the OCC is coming in through the door and then going up the belt that's off in the back up into the pulper. And the next slide will give you a better shot of what that really looks like. Here is the pad at our mill. So as you can see to the left and out back is a stack of OCC, and then the OCC is brought here to the belt, which it goes up the belt and into the pulper to break down the fiber. The next slide is a similar picture, and this is showing the 3 belts taking OCC up the line and putting it into the pulper. And these 3 belts that you see here, this mill produces about 1,500 tons a day. So these 3 belts are basically handling OCC all day. Next. That's just a shot from up top showing the yard. So we could here, and I know that that we touched on this earlier in the presentation, but with the 10% recovery rate of pizza boxes and craft bag, that would represent about 2.3% of an OCC bale. The percentage and half of that would be craft bag, and then less than 1% would be pizza boxes. And for us, with our manufacturing process, we assume that there's pizza boxes and craft bag in the OCC bale, and these minimal concentrations would not negatively impact our manufacturing projects from making new paper. So we do not have an issue at all with the pizza boxes or the craft bag being in the OCC bales. And that's it that we have for Rand Whitney.
Great, thank you. I think the interesting piece there is, you know, when we were working on setting up this webinar and trying to get the whole process of from start to finish, from MRF to market, where do we see successful food service packaging recovery going on? The answer is yes. So let's look at to Boston as a good step-by-step from the MRF perspective, from a cleanliness perspective, and for a singular material for the end market perspective. But even when we were discussing this webinar as a group yesterday, there was still, you know, nervousness a little bit about pizza boxes. So the ability to be able to understand how much could effectively be in a bale gives you the confidence to say that this is not an issue for you, and so it allows you access to good material. Is that fair to say, Jeff?
It is. I mean, as long as, and we touched on this earlier, but as long as the MRFs can keep the food waste out of the actual packaging. I mean, if there is significant food waste or a stench coming off the bale, that's going to cause problems for us. But as long as there's really no food contamination in this packaging, then it's fine for our process.
And you know, one of the things I mentioned earlier when we were talking is that cup sleeves could be an additional corrugated material in there, and that would be a good source of material for you, right?
That's correct.
Okay. Let's see. Let's get to a couple of questions. Ted, let's start with you. There's a bunch of questions about your study. I wondered if you could speak to a couple of things. What about, three things, let's start there. What about Boston makes it so clean, one? Do you think, well, I guess to expand on that, what about Boston makes it so clean? Is that a public education? Why the noticeable cleanliness level? Two, any concern about EPS and PLA in your mixed plastics there, or any difference in those food contaminations that you saw there compared to the PET thermoforms that you referenced? And then finally, you do waste sorts all across the country. What sort of food contamination levels could you comment on some of the other ones?
I'll start with the clean, and I don't know the answer to this. I suspect it's a combination of good education on the part of Boston, a recycling program that has been around for a long time, and is surrounded by communities like Cambridge that also have a long-running recycling program, so there's a lot of good education. But I'm speculating, and we talked quite a bit about it when we were doing the sorting, that another reason may be that because a lot of the dwelling units are small and tight and there's not a lot of storage room, that most of the recycling storage is done in the home, and therefore people are pretty careful about keeping it clean. But that's just pure speculation. I don't know why it was so clean, but I was sorting with, as I said, MSW consultants and my sorting crew, and we sort a lot of waste and a lot of recycling, and it definitely was very clean recycling.
Okay.
As far as expanded polystyrene or PLA, we saw very little of it, but remember any of the EPS or that was in the refuse would have been thrown out as not recyclable, and in the recycling it would have been thrown out as contamination. The average contamination rates for the single stream material in Boston by neighborhood were around 8 to 9%. So they were in what I consider to be the kind of acceptable and normal range. But we weren't specifically looking, in the case of PLA, we weren't looking for it. And having done the plastic subsort in Vermont where we were looking for it, we didn't see very much there, and I'm not sure we would have seen very much in Boston. I can't remember what the third question was.
The third question was, you do sorts across the country, those have not focused on comparing food service packaging to other food touching material, but wondered if you saw any other trends from your other audits and sorts across the country that you could comment on.
Well, clearly the big trend is that newspaper is disappearing, and plastic packaging especially is increasing. And so, not surprisingly, what we saw in Boston was a large number of tubs, lids, and especially PET thermoforms, and that's clearly the growing component of the recycling stream that we're seeing. As the paper's shrinking, the packaging is increasing.
Okay. One more question for you, and then we'll pick on Bob for a bit. Curious about the cans that you used in the study. Did you use any or see any pet food cans, or was it were those included in the audit, or was it just human food?
No. For the aluminum cans and trays, pet food cans were the primary source of food contact packaging for aluminum were pet food cans. And so, yes, we were looking at them. We did not, and I probably should have said this at the beginning, we specifically excluded beverage containers from our sort. Casella did a separate beverage container subsort for their own information, but we were not looking at beverage containers per se. So we weren't trying to say that a aluminum beer can was clean or dirty, but we were looking for food cans, and for aluminum cans, it's primarily pet food cans that you would see.
Okay, excellent. All right, Bob, you mentioned the term zero tolerance for food waste, but we all know that there is some residual that comes through, and in the grading that we saw in Ted's study, we certainly see, various levels of food residual. We also know that the end markets expect and can tolerate just a little bit, but can you speak a little bit or expand a little bit more on, we know you're going for quality, so when it comes to food residual, what do you see, how do you use education, what's the appropriate threshold?
Yeah, and from a zero tolerance, I say that from a quality standpoint. I don't say that from an incoming standpoint, inbound material. Zero tolerance meaning if I'm selling to Jeff Riles at Rand Whitney, this should be, our guys are trained from a MRF standpoint that this should be zero tolerance from a food waste standpoint. I mean, from an inbound standpoint, when it hits the tip floor, I go back to that partnership and relationship, and the first time it hits, it has some food waste in it. We know who the generator is. They all come across the scale, and we're working with that generator to get out there and educate them, backtrack of where it came from, because it could be a hauler that picked up a particular street or a particular commercial building. So it's more of zero tolerance from an end product standpoint. When it hits the tip floor, there isn't. I've been here since 1999 in Boston at this Casella facility, and I don't think there was a customer that we haven't remedied with regards to a food waste. So.
Okay. Let's see. Good. Jump around just a little bit, but Bob, do you see any of your facilities trending towards accepting plastic bags? And then we'll start with you, and then maybe put it to the panel of discussion to stepping outside of traditional plastics.
Yeah, it's we've been approached from an equipment standpoint. The barrier is two things. A, what is the percentage of bags, grocery bags within the stream now? We estimate anywhere from 1%, and then to extract them and capture them, you're looking at maybe a vacuum system because you just can't do it from a manual standpoint. So you're looking at some equipment that could, hundreds of thousands of dollars. So over a period of time, you have to, is that return there on 1% versus the investment of that material? And really the second piece is I went back to, it's so important from a MRF standpoint to continue what we call uptime. And uptime is that system is continually running, and each one of our managers are shooting for 90% uptime, which includes breaks and lunch and whatnot. And if you open the gate, for instance, in the city of Boston for acceptable grocery bags, you will probably be affecting throughput. You'll have to start the belt. So it's that finding that balance of the return on the investment, finding the balance of throughput, and quite honestly, we are looking at a couple of our MRFs to going through the performance now to see if those systems would work.
Okay.
So it could be on the horizon.
All right. Good to know. I was in a Burtech facility not too long ago, baling lots and lots of film, and successfully getting it out first off, but kind of in line, I think, with what you're saying about a trend to that material. So one more question for you, Bob, and then we'll switch over to Jeff. But wondered if you had any problems marketing material that contain food service packaging?
You know what, we have three mottos. It's safety, quality, safety first, quality, and productivity. And once you get beyond safety, it's all about quality. I can tell you from a food service standpoint, we took the baby steps with the pizza boxes 4 years ago, and it's proved to work out well. We have not had any downgrades or rejections, so-called downgrades or rejections. So off the top of my head, I do not know any of the food service packaging that caused any type of contamination or downgrades.
Okay. So one more question came in, kind of that, just a clarification. So you said that if Casella sees too much food waste in the packaging, it's sent out as residual, as waste. So trying to get a handle on how much is too much, what do you think about the categories that that Ted displayed there? Are those in line with your understanding of kind of thresholds and variances of food residual?
Yeah, I look at it. It's really nice that he placed them in categories, where 1 being very clean and 5 being food waste. And let me just clarify too: if material comes in from and it's contaminated with food, we do all we can to salvage the non-contaminated load. So 20% of it may have food in it. We try to separate that out, throw it in the trash, and then anything that still is not contaminated, we could run through the system if possible, as long as it's not contaminated with food. So I just wanted to clarify that a little bit. But looking at Ted's pictures, and maybe this is a good segue in with Jeff, I would look at maybe 1 and 2. 1 obviously is great, and 2 would be acceptable. You get to 3 and 4, now you're tipping it a little bit, where you might it might be too much contamination.
Okay. All right. So Jeff, could you speak a little bit to barrier-coated? If you see a barrier-coated pizza box, does that affect your OCC bale differently?
I'm sorry, did you say carrier-coated?
Barrier, a barrier-coated.
A barrier-coated. I'm actually not familiar with that. Could you elaborate on that?
I think what they're referring to is if there's a thick poly lining in there or some other coating. Do you see a multi-layer or coating material functioning differently? I think for the purposes of generation, the majority of this material is either a box board or a corrugated cardboard, and does not. When we're talking about pizza boxes, there are not a lot of lined ones.
That is correct. I mean, anything that was lined with any kind of poly or film would actually take longer for it to break up in our pulp, and longer for us to process, and could also leave you open to possibly leaving some white marks or spots on the paper. So that high concentration of that type of material certainly wouldn't be good for our process. I don't see a lot of that coming in, coming through our door. So luckily for us, it has not been an issue.
Okay. I do have a series of questions here about Polycoat, and I think we'd look to Lynn to speak a little bit to them. Questions, the emphasis here really being on cardboard and OCC. Next year when we work on more webinars in this series, I think we'll continue our trend of focusing on materials, and Polycoat will definitely be one that we'll focus on. But Lynn, can you talk a little bit about the project's work to expand markets and recovery options for polycoated cups and takeout containers?
Sure, absolutely. Obviously what we're trying to do is look at all the various options for those end markets, and in some of the research that we're doing, one of the things we've tried to do is figure out, if you take a look at the whole universe of food service packaging, what kind of coatings are we talking about? Because I think most people, when you talk about paper food service packaging, they're going to assume that the majority of it actually is coated with some sort of, typically a PE coating or some sort of plastic coating on it. But in fact, based on the research that we've spent a lot of time doing, keep the number something like only 30% or a third of food service packaging, paper food service packaging, is actually polycoated. The vast majority of the paper food service packaging is actually clay coated, and from our understanding, that is not a problem for a lot of the mills. So one of the things that we're trying to do is, once you do take a look at some of the different types of paper food service packaging that's in the marketplace, how much of that can be going into, let's say, a bale specifically for polycoated products, like a typical bale spec 52 where you find your cartons, your multi-layer containers, or is it going to go into that that mixed paper bale? And so one of the things that we're going to be doing in the next couple of months is actually running some tests to take a look at what happens when you start adding more polycoated food service packaging to either one of those bales. What actually happens to that? Are there problems either within the MRF, within the end markets, at the mills, et cetera, et cetera? So definitely something that we're interested in, but also trying to break down some of those barriers and some of those misunderstandings about what's actually out in the marketplace right now.
Very true. So look for more details specific to polylined material in the coming year. I do see a series of other questions about labels and about EPS, but I think we're about out of time now, so might look to follow up with a couple of you by written response to your email afterwards. I do want to thank our speakers today for their time and effort in participating, not just in this one webinar, but in the ongoing work of the FPI, PRA, PRG, and working to solve these MRF-to-market solutions for more recyclables. So Jeff, Ted, Bob, really appreciate your time. If you in audience land want to know more, you are welcome to contact Lynn or her counterpart Natha there at FPI, or you can reach out to me. And the FPI website is there at fpi.org/stewardship to learn more details. Thanks again for everyone for your time. Speakers, you want any last words from you?
Just thank you on my side.
All right. Thanks, Bob.
Thanks for having me.
All right. Thanks, Jeff. And with that, we look forward to seeing you on the next one, and appreciate your time today.
Okay. Bye-bye.
Bye-bye.